Hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, online classes, subject code ME8791, title Mechatronics, unit number 3. Myself Saranan, Assistant Professor in Mechatronics Department. Course objective and outcome of Mechatronics, syllabus, textbooks and reference, and unit 3 syllabus. Okay, so last unit 2 we discussed about microprocessor and microcontroller. In that microprocessor, I said one point, that is in microprocessor there is no input output port. Okay, in microprocessor there is no input output port. Okay, that means if you are connecting the external devices with the microprocessor, only use of the interfacing devices. Okay, so that is the programmable peripheral interfaces. Programmable peripheral interfaces, these are used for connect the external devices with the microprocessor and microcontroller. So that is a concept we are going to discuss in this unit number 3. In this unit we are going to discuss as a 8 chapter. So first chapter is 8255, that is programmable peripheral interface, then keyboard interfacing, then LED, then ADC interfacing, then DSC interfacing, temperature control, stepper motor control, and traffic light control interface. Like that, we are going to see 8 interface in the unit number 3. So let's see one by one. So today we are going to see about the architecture of 8255. 8255 programmable peripheral interface. That means in 8085 microprocessor there is no input output ports. If you want to connect the external devices, you need to create the ports. So they are connecting the 8255 with the microprocessor. Okay, so these are the signals. These signals are defined by the microprocessor. These are given to the 8255 for controlling the 8255. So these are the input output devices. That is output of 8255. Okay, if you want to connect the any devices, means you can connect any port with this processor. That is programmable peripheral interface, which is used to generate the input output ports. Okay, so let's see architecture of 8255. In 8255 we have 3 ports: port A, port B, and port C. So they are defining the total ports in the 2 groups. One is port group A. So group A having port A and upper C. That is port C oda upper on they are defining. Then group B, it is having port B and group C lower. Okay, so totally they are divided into the 2 groups. Okay, total 3 into 8, 24 devices we can connect with the 8255. Then we have a group A control and group B control for generating the control signal between the group input output ports. Then data bus buffer, that is a bidirectional data bus buffer that is derived from the microprocessor for accessing the data in the 8255. So then read write control, that is already we know that read write operation A1 and A0 and reset. And A1 and A0 used for selecting the which port we are going to do. Which port we are going to select, like that, done by the A1 and A0. Then reset operation for reset. Then shift select CS. So CS means shift select to enable the read write control logic. So power supply for 8255 will given from the microprocessor, that is plus 5 volt, and ground given from the microprocessor. So this is the basic internal architecture of 8255. Function of pins. So data bus D0 to D7, these are 8-bit bidirectional buses connected to 805 data bus for transferring data. CS, so this is active low signal. when it is low, the data is transferred from 8085. Read. So this is active low signal. When it is low, read operation will be start. Write. So this is active low signal. When it is low, write operation will be start. So these two lines are used to select the port as follows. So if A1 and A0, if both the values are 0, it is select the port B. If value 0 and 1, so select the port B. If 1 0 means select the port C. 1 1 means it will select the control register. Then reset. So this is used to reset the device. That means clear control register. So PS0 to PS1, it is the 8-bit bidirectional input-output pins used to send the data to peripheral or to receive the data from peripheral. Okay, PB0 to PB7 similar to PA. So that is a port B. Port C, this is also 8-bit bidirectional input-output pins. So these lines are divided into two groups, PC0 to PC3 lower group and PC4 to PC7 as a higher group. So these groups are working in separately using 4 datas. Then data bus buffer. It is a 8-bit bidirectional data bus buffer used to transfer between 8255 data bus with the system bus. The internal data bus and the outer pins D0, D7 pins are connected in internally. So the direction of the data bus buffer is decided by the read and control logic. So this is a read and write control logic. This is getting the input signal from control bus and address bus. This is getting the input signals from control bus and address bus. Control signals are, so control signal are RD and WR. So address signals are A0, A1 and CS. So 8255 operation is enabled or disabled by CS. Next, group A and group P control. So signal from CPU and send the command to the individual control blocks. So group A send the control signal to port A and port C upper, that is PC7 and PC4. Group P send the control signal to port B and port C, that is PC3 to PC0. So this is the control word format for the selection of group A and group P, as well as so select the mode of operation. Okay, first D0 and D1 and D2 so represent the group B control, that is port C as a input. Port C, if D0 is equal to 1, so the port C is input. If 0 means port C is output lower. So same as D1 represent the port B, that is input. If 1 means port B as a input, if 0 means port B as output. So same as mode selection, they are using 0 and 1. Then group A, port C upper, so that is 1 and a input, another 0 means output. This is the port A condition, same as mode selection, same as select the mode select of active. If D71, then only remaining value will be enabled. Then modes of 825. So 825 work in different modes, that is mode 01, mode 0 and mode 2, then bits reset mode. Okay, first mode 0, simple input output mode. In this mode, port A, port B, port C is used as individually, that is simply. So features, outputs are latched, inputs are buffered not latched, ports do not have handshake or interrupt capability. So mode 1, asynchronous and interrupt drive. In this mode, input or output is transferred by handshaking signals. So handshaking signals is used to transfer data between those drives. Those devices whose data transfer or rate is not same. In mode 1, port A and port B use the lines on port C to generate or accept these handshaking signals. This is the mode 1 operation of input control signal. This is the output control signal of mode 1. Next to mode 2, bidirectional operation. So in this functional configuration provides a means for communicating with a peripheral device or structure on a single 8-bit bus for both transmitting and receiving data. That is bidirectional bus input output. So handshaking signals are provided to maintain proper bus flow. So discipline in a similar manner to mode 1. So interrupt generation and enable or disable functions are also available. So mode to bidirectional operations. Then bit set and reset mode. Okay, that is Bsr mode. The port C can be set or reset by sending out instruction to the control registers. The control word format for the Bsr mode is this one. Okay, first bit select the bit or set or reset for the particular condition. Then D1, D2, D3 select the bit select data. Then remaining 3 are don't care condition. Then bit set of active signal. So these are the 8255 operations in the peripheral interface, which is used in the most of the applications. When we implement a microprocessor for a project, we need to know about the different kind of 8255 programmable interface devices. That is 8255. See the each and every part in the 8255. Okay, this is used in the different applications like motor communication, um, interfacing of LED with the 8085, interfacing of keyboard with the 8085, like that they are using. Okay. So we again will see the control word format in detail. So there is control word format which is used to select the first we into how to select the control word format. So that is if A1 value and A0 value will be 0, 1 means it will select the control word register or control word format. So in this format, first D0, D1 and D2 represent the for group B. Second D3, D4, D5 and D6 represent the group A. Okay. In group B already we told that is port B and port C lower. Okay. So that means if D0 is equal to 1, port C act as a input device. That means it is access the data from external device. If 0 means it can send the output from microprocessor to external device. This is the concept. Next port B. So if D1 is equal to 1, it is act as a input. That means it can access the device from data from external. Then 0 means output. So mode selection 0, that is mode 0, 1, mode 1. Group A, that is port C upper, 1 is equal to input. Next is 0 is equal to output. Next to port A, 1 is equal to input, 0 is equal to output. Mode selection 0, 0 means mode 0. So 0, 1 means mode 1. So 1x means that is mode 2. Whatever it is will be 1, 0 or 1, 1. That is mode 2. Next D7, that is select the mode of set value, that is flag value is equal to 1 for active. So different modes. This is the mode 1 operation input control signal. This is the mode 1 output control. Then bidirectional operation gonna control signal, then process. This is 8255. So it is one of the best interface in the microprocessor communication. Okay. So next class we will see the keyboard interfacing and the LED interfacing. Okay. So keyboard and interfacing we can directly connect with the 8085. 8255 also we can connect the directly with the 8085. Okay. So for keyboard and display, they have a separate controller, that is 8279. So not in our syllabus, but we need to know so what is 8279. So which is control both keyboard and display. Okay, we will discuss in the next class. Okay, thank you.